मगर इस देश रहना चाहिए, इस देश का लोकतंत्र में रहना चाहिए।
You can do one Mumbai, you may lose Balochistan.
2-1-0. S139
And this
mortar.
man is a horrible man. He must be shunned.
For them to count. Our job is to hit the target, not to count the body bags.
नमस्ते सर, वेलकम बैक टू द शो। ग्रेट टू हैव यू बैक वंस अगेन, जैसे हम ऑलवेज करते हैं।
Same here, and it's always good to be back doing our podcast, dealing with technology and geopolitics. Yeah, tell me.
So I think, sir, we are just going to cover today the frequency bands and spectrum map. So audience, what is frequency band? What is spectrum map? These are some of the more technical jargon or language that we use when we want to describe communication technology. So, but then all of this communication technology affects us on a day-to-day basis. So it is kind of important for us to understand like how these things work so that we can learn more about them and be aware of what it means to use these things in our day-to-day life. So sir, let's begin.
Okay, this being one of our favorite topics because my research and my telecom and communication career has been a lot on frequency bands and equipments. So yeah, this will be fun. Chalo, let's move ahead.
Okay, this is the first one.
Okay, so I think we'll discuss the invisible battleground. That why invisible? Because radio frequencies we cannot see, and why it matters because that only carries information, right? So whatever speak, whatever intelligence we want to send it across to the receiver depends on this how we manipulate and modulate the radio frequencies. Frequency bands we'll discuss because these are important. We don't understand in a normal sense, but there are a lot of concepts and technologies involving which band to use, why to use, which is good for one technology, which is not for the other. Spectrum maps, we'll just visualize and manage the airways, how they go in a very brief explanation. Then we'll talk of something which is getting popular, the near range communications, the Bluetooth low energy mesh, Wi-Fi, direct, and other, their friends. One case is the Jantar Mantar, and the last podcast we done on Jantar Mantar. And what are the implications and takeaways, the policies, the surveillance, the resilience? So we go through all these aspects, but in a limited time, just to explain our viewers and give them sufficient understanding of these topics. We go ahead.
All right.
So what we understand, the radio frequency spectrum, it is a finite. When I say finite, it is limited. So limited in the frequency scale, and it is a natural resource. The frequency band is a natural resource for the specific country. Each country, it is a resource which the country commands, decides whom to allocate, whom to issue on a license basis, and it can take back whenever there is a national emergency. So what the set of all electromagnetic frequencies for wireless communication, we can say this is RF spectrum. Okay, and it is used for telecom or satellite, or you can say communication system technologies. So first of all, it is finite. Only so many usable frequencies exist, so many users can be there. So crowding and then contention is there. So we have to control. In India, WPC Wireless Planning Commission, which is in the DOT, decides it under DOT and licenses it. Various Department of Telecom, which is the ministry, handling this spectrum space. And this overall over the world, the ITU governs it. ITUR, International Telecom Union, the radio part governs this. For India specific, there are regions, and in India, WPC does the same.
Right.
International coordination, so with ITUR, we do the coordination. ITUR tells us what are the, like say for 6G or say future satellite communications, what are the technologies which are going to come. Okay, excuse me. What are the technologies which are going to come, and what we are supposed to allocate which bands for which new technologies. As per the ITU's regulations, the WPC and DOT, they decide and distribute allocate frequencies to defense and civilian and other users. These are all dual use in nature because the same frequency band can be used for military radars, can be used for civilian phones, for emergency service. But what has to be done by WPC? is that the allocation is such that if it is used by DRDO and it is used by Airtel or ISRO, it should not interfere each other. The operation should be interference free. I have handled cases where telecom, towers were interfering satellite communication or NAVIC, where the interference mitigation was required. So hence, anybody can use it. Is technology independent, technology agnostic. Hence, one has to plan which user should use in that specific area. Even as we move from geographical area, we can use the frequency, which is called as frequency to use. So in one area, I can use one frequency for one user, and the next area, I can use the same frequency for some other user, for some other application. So as we know, whosoever controls the spectrum controls the ability to communicate at a distance. Internet shutdowns, near range communication. Now, these we'll discuss in detail. Next slide.
All right.
So if you see the band in a linear scale, what I'm talking, what you are hearing is what we call as a voice spectrum band. So zero point 0.3 to 3.4, 0.3 to 3.4 kilohertz is the audio band. Our ears are able to listen till 20 kilohertz. So zero point 0.3 to 3.4 is what we speak, and till 20 kilohertz is what our ears are willing to can hear, have the capacity to hear.
And
Beyond
the
that,
difference being that when we are speaking, those are mechanical waves, whereas the
no,
ones that I think sir is
no, no, no,
talking about is the electromagnetic waves,
no, no.
right?
Yeah, so these are audio waves. When I say
Yeah, which is
our
mechanical.
no, so see, audio is mechanical, but when I convert that into a telephone system, into a system, so when I have a transducer, when I speak on this microphone has a transducer, what I speak is converted into electrical pulses,
Correct,
and
correct,
those
correct, correct.
pulses go through the waves, and then they define that spectrum of the RF band.
Right,
Okay,
right, right,
mechanically, my
right.
voice throat is talking. The mechanical, voice valves are moving on. But when this audio waves hit this transducer, which is a sensor, it converts it into electrical pulses. That
Yes,
electrical pulse is from zero point 0.3 to 3.4 kilohertz.
yes, yes, yes,
Here, what
yes.
we can hear is in the audio range is till 20 kilohertz. So the spectrum starts beyond that. From 30 kilohertz to 3 megahertz is called as low frequency. And it is used earlier in, even in defense, it was used for AM radio. Uh, Further, and other navigation and naval applications also. Next, we go to high frequency. So from 3 megahertz to 30 megahertz. This is shortwave, ham, also all defense radios, HF radios. And HF radios generally employ propagation model is sky wave. So the wave goes to the ionosphere, turns down from the ionosphere. And because of this, there is a skip distance, minimum distance, but the distances, coverage distance is very large. So I can have a HF radio in India and I can communicate in Africa or Europe. I remember in my earlier years, we used to have these HF radio links as a, what do you say, a hotline between countries. So between India and Russia and Moscow, Delhi and Moscow, Delhi and say London, Delhi and US. So these HF waves can travel global distance. Hence, during non-war peace times, the HF radios are not open, not allowed to be open. I remember in Parakram that we opened these HF radios because during wartime only you're supposed to open these radios. Otherwise, you're supposed to test and keep it down, and only in emergency you're supposed to. The ranges are huge. Just understand, as with the lower frequency, the ranges will be limited. As you go higher in the frequency, the ranges, communication ranges will reduce. So as energy increases, the data rate speed will increase, but the range will reduce. Then we go to VHF. VHF follows space wave propagation. That means just above the surface of the earth, and generally 50, 60 kilometers is the range. HF can have thousands of kilometers, but because ionosphere say it is turning and coming down. VHF will have limited range, say 50, 60 kilometers, 30 kilometers. It is from 30 megahertz to 300 megahertz. Generally, your FM radio, your TV, they are used. If you see if a FM radio in Bombay or Delhi, you'll have till 80, 70, 80 kilometers, you'll find your car receiver, FM receiver is able to receive it. TV also utilizes this band. Okay. Then we go to ultra high frequencies from 300 megahertz to 3 gigahertz. This is where, and in UHF also there are sub bands, L band, S band. Okay. So generally 1 to 2 gigahertz is L band, 2 to 3 is S. So that is how it has been defined. The Cellular in India uses 900 megahertz, 1800 megahertz, 1900 megahertz, 2300 megahertz. This is what the 3G, 4G, even 5G systems also use this. The 5G in India in the mid band comes in SHF, super high frequencies, and they are from 3 to 30 gigahertz. Okay, till 3 gigahertz is UHF. 5G came in 3.5 gigahertz. Wi-Fi also is in 2.4 or 5.8 gigahertz. Okay, even Wi-Fi is also there in UHF. So some as per band, some usages are split,
Overlapping also.
overlapping. Yeah. Uh, the super high frequency also has the application of satellite. In satellite, there are different sub bands. We call it as C band, 4 to 8 gigahertz, K band, KU band, 18 gigahertz, Ka band. So these are the bands till 30 gigahertz. You'll have satellite bands also. So all your satellite communication in the ISRO, even the defense DRDO, they use this 3 to 30 gigahertz. And extended high frequency is 30 to 300 gigahertz. So millimeter wave generally 36 gigahertz, 850 gigahertz. These are millimeter wave. This is where you use for radars as well as millimeter wave specific applications. So this is the band, uh, you know, scale, and as per the various applications, you can see what all can be used. And advantages, as you go higher the frequency, the speed or the data rate, amount of data you can spend put in that band is higher, but the ranges reduce. As you come low in the scale, say HF, you will find the ranges are huge. Even LF, which may be used in submarine and other communication sonar radar. So you find that the ranges are quite high, even underwater. So this is how the spectrum band is there. That's what is written low, in the viewfile. Lower frequencies travel farther and penetrate buildings better. Higher frequencies offer huge bandwidth, but line of sight, and they're easily blocked by obstacles. Bluetooth is
And
2.4. Yeah, yeah.
and I was saying my experience with the EHF band was, I think, when I was in America. So for some of the 5G bands, I think they have like Verizon has one specific millimeter wave 5G also, where for very short distance, like at the airports or some kind of public place like that, they will have it where literally I can download like hundreds of gigabytes in a matter of minutes, which is
So
available, and it
5G,
was
5G when it was launched, it was meant for millimeter wave. In the interval, it was launched in millimeter mid band 3.5 gigahertz. But what happened when the trials went for millimeter wave in India? Also, 26 gigahertz, 38 gigahertz have been allocated to Airtel, Jio, and
Hmm.
other
Hmm.
telecom service providers. But what happened is that at this band, the ranges were so less, and for that millimeter band, very few one odd mobile phones are available. Hence, the phone ecosystem did not develop, and the ranges are too less. It is something like Wi-Fi. Hence, the millimeter wave did not come in for 5G in India and other global countries in that big way.
Hmm.
Just an
I
input on
think
that.
most of the high-end phones, which are global phones in India, they do support it, but I think the volume of those devices is very less compared to the total number of subscriber base.
Because millimeter wave did not do well in the
Hmm.
5G market space.
Correct. So,
Next.
on the next one, this is how normally it is. I think what Servo was describing, all the mid band is there, GPS is there,
Yeah.
cellular is there. This is exact same thing what Servo was saying in a more
Just
different
one
way.
point just one point that 2.4 is the ISM band, industrial scientific medicinal band. That means anybody can use it for industrial or scientific medicine purpose. You don't need a license. So there are bands are two types. One is licensed, one is unlicensed. When I say licensed, that means you have to take this license from the government. Maybe you have to pay administrative charge, or on an auction. People can go for an auction. Unlicensed bands are which are free for public. So first one is the 2.4 gigahertz ISM band, industrial scientific medicinal, and the next one is 5 gigahertz. Okay, this is again national infrastructure for unlicensed national infrastructure band. 5.5 to 5.8. That's why you find the Wi-Fi. The old Wi-Fi routers were in 2.4. Even your cordless phones, BTEL and other cordless phones, which everybody that was in 2.4 gigahertz because you don't need a license. Initially Wi-Fi routers were in 2.4. Now they have come in 5.8 because the speeds are better in 5.8 because
They will
higher.
have dual band. Nowadays, you will see that there is
Yes. You have
2.4
all dual
option.
bands, 2.4 and 5.5.
Yes,
The ranges
yes,
will be higher in 2.4 and the ranges will be lesser in 5.5. The
yes,
cellular, I've already explained that from 700 till 2600, the cellular bands are there in India. 5G mid band is 3.5 or 3.8, and GPS again we see 1575, and sub gigahertz 433, 868 generally are used for LoRa. This we'll discuss IoT devices, within sub gigahertz bands,
yeah.
ISM bands. Yeah.
So then next, I think one part we can discuss is like how do people know like what is it that these are allocated for? So there are some official national tables like for government publishes this information
Okay, just
so
for
that
your
people will
information,
know.
as part of Telecom, TRI and Airtel, I've been part of National Frequency Allocation Plan 2027, where we've given inputs from our organizations that what band should be now shared, or if the government is not using some frequency band, it should give it for the telco or the Wi-Fi industry. So all this discussion happens in the ministry DOT, and after that consultation, final the National Frequency Allocation Plan is decided. Once the plan is decided, every user is supposed to follow that national frequency allocation plan. Every country does it. For India,
Correct,
DOT.
correct,
So there are heat maps also. So real-time historical measurements are done. SDR networks are, spectrum analyzers are placed, and people keep measuring it at sample points to know that nobody is interfering the other band. Those who have been allocated are using their authorized or licensed band. And propagation coverage maps also there. So all cellular providers, even satellite telecom providers, what they do is they go through and do propagation planning, signal strength planning, and there are various models which they calculate while deploying their products or equipments. Next slide. So what is the advantage of these near range communication models? So we all know that HF, VHF, satellite telco are for larger distances. But what if the communication distance is less than 300 meters, 100 to 300 meters? Though let me tell you, in telecom, these are called as pico and micro cells, okay, or femto cells. But that is when the telecom infrastructure is used. Here we are talking of an ad hoc network with a long range and typically less than 300 meters, where there is no telecom infrastructure. Every phone is its own infrastructure. So there is no central network, there is no switch, okay, no tower. The Bluetooth of your device is used, various like Bluetooth low energy protocol may be used, and more phones communicate with each other, cooperative communication. So I will communicate to your phone, you will communicate to the next phone, and we create a mesh network which is independent of any telecom infrastructure, and we create this mesh network which cannot be supervised and uh, regulated by any government agency. For jammers, they have to come close. For cellular towers, I know if there's a big tower in the city, I can concentrate my jamming energy into it and jam it, make it non-operational. But these networks, I don't know where they are working because they are not in my control. And with a spectrum analyzer, I don't know which area because their range is only 300 meters. These are small, quiet networks which are working independently without any control and any regulation, any announcement. Hence, it is very difficult to geofence and jam.
right.
Next slide. So Bluetooth Classic versus Bluetooth Low Energy. Classic Bluetooth was designed for continuous audio streams, but Bluetooth Low Energy is optimized, so it only transmits short packets intermittently. Aim is to save the battery. In tower and cellular infrastructure, you got huge gen sets and batteries there. But for these networks, your handset is the telecom equipment, and the handset needs to be is powered by battery, and the battery needs to be efficient, and you want to save the power of the battery. Hence Bluetooth low energy has been designed so that you can create networks without consuming very high energy from your handsets. So short packets perfect for messaging, beacons and sensors. Modern phones support both. Now, mesh networking mechanics, each phone broadcasts short packets on BLE so there are advertising channels where you can transmit. So the channels are allocated in such a way that you don't uh, interfere the other. So everybody should not start transmitting. There's a protocol which decides when to you should transmit, when you should keep quiet. Nearby phones running the same app, so they know when to transmit, when to rebroadcast. Hop by hop, the messages are transmitted. Say 5 to 7 maximum. They support 8 hops. your message will be transmitted to the last user. Even if there are 100 people constant in that area, say there's a protest site, or there's a music function, or there is a lecture, or there is any dharna, all the phones which are there within the 300 meters, your message will reach them within, say, 8 to 10 hops. 8 hops is the maximum. So there is no requirement of SIM. There is no requirement of any account authorization, no central server monitoring, no tower infrastructure, no core. Encryption is implemented from the phone itself, from the application itself. So again, it works on 2.4 gigahertz. Typical hop outdoor is 10 to 100 meters. Maximum less than 7 hops it should allow. Very limited power transmitter. So in micro or milliwatts. Hence, no spectrum analyzer, no sensor can detect there is a transmission going on. 40 channels are there, so enough for, say, twice or three times users. Okay, 200 users can also handle, because everybody will not be transmitting at the same time. And these are small bursts, and as per your round, you will be able to transmit. Okay, next.
So these are
So
the
here,
ones tools that we covered in the previous podcast.
so bit
This
chat we have
is
covered. Bridgeify is another one which uses the same slightly modified. Briar. Mesh statics is again low range, long range based sub gigahertz, again less than 1 gigahertz. So it may use ISM band. It may not use it may use other sub gigahertz band, not ISM band. Okay, so 400, 600, 800 megahertz. And for longer ranges, this is for longer ranges compared to BitChat and Bridgeify, which are for Wi-Fi using Bluetooth 2.4 gigahertz. This uses sub gigahertz for longer range, till 1 kilometer.
and
Dedicated
usually
hardware
it's not found on the phones. You need a separate module or something for
module
that.
for that. But it is possible. What
Yes.
point is that you can create your own network with limited hardware without using the government or national infrastructure. Wi-Fi gives higher bandwidth, so you can also work in 5.8 gigahertz. Phones can create an ad hoc network using Wi-Fi also, or Wi-Fi routers. Wi-Fi router is very simple. So you can put a Wi-Fi router, and everybody can communicate through it. NFC is again near range, which we are used in cards, credit cards, so contact cards. So through
Tap to pay.
yes, tap and pay. So, but NFC protocol can also be used for communication of short messages. Okay, these are just examples.
Yeah.
Next.
So this is again what happened during that time. Like in the protest, some people try to take this the wrong way, and then whatever technology was there, they try to misuse it this way. So then the
So
I4C,
just
which is the
my input in this, even atomic technology, atom bombs were for constructive use, but somebody put it in Hiroshima and Nagasaki for a destructive use. It can be used for power generation, but it also can be used to kill people, millions of people. In the same way, all these technologies have been developed for constructive uses, but you can use it for a negative cause by such applications.
yeah. And overall, so with the mesh, right? So how does the mesh networking work, right? So you have phones which are nearby. There is Bluetooth advertisement happening. Oh, I'm this, so I'm this device and this device. Then based on that, the apps can connect to each other because they already installed. Then they form some sort of relay. Like one person can send to another, another person sends to the third person, and then it is like offline kind of network. So it's not connected outside.
So no
So,
telecom infrastructure, no government agency can interfere, no regulation.
yeah. And then, so what is the frequency angle here, right? So if you see, like the people who are using this, they are all using the ISM band, which is a licensed band. People are, like Sir said, it's meant for having good use out of the particular tool, but some people are misusing it. But if you think about it, like, so what is the reason that people are trying to use it? So the low power area which is there for these things, it makes the jamming inefficient. So if you want to have effective jamming for this for the agencies, so then you need to have a high power density and near to the area where it is affected. So all these kinds of things are there why people were trying to use this. And then accordingly, authorities face challenges in this area, which are described in the slide right here. If you think about the next thing, so what are the implications in open questions? So people say, oh, actually this is for civil resilience, like we should not have oppressive government, so they like to say that it is for that purpose. Then then they say, oh, but then government is like, if they are using it this way, then maybe it should not be given to them. So there is a tension in the regulation, and then there is the implementation use in practical reality. So, which is why we were talking about dual use, meaning it can be used for civilians and by the armed forces or the police, the government, but it can
The
also
dual
be
use,
used in a negative way for people who are doing things in a wrong fashion for negative intent.
so dual use can be for regulated networks of the government and unregulated mesh add-on networks for say hikers or any small party organizers, but not for people with a wrong anti-national intention.
Yes. So then, in the end, to conclude, so this spectrum is the reason why we are able to have all these kind of advanced technologies. We are having the ability to actually have the range to achieve these things in complex in areas using 5G and other things. And then technology, which is a universal truth, it is dual use. It can be meant for good purpose, but some people will misuse it, just like any other tool. And I think that's pretty much what I wanted to cover, sir.
I think we had a decent, explanation for our viewers, understand spectrum and understanding these new ad hoc networks. So I'm sure they'll enjoy this, and we look forward to such more exciting, communication podcast for
For sure, sir.
relevant to today's world.
Yes, sir. So I think that concludes it. Jai Hind, sir. See you next
Jai
time.
Hind.